Assalamu alaikum and a very wonderful welcome again to everyone. This is Geotechnical Engineering. We're gonna move on to the next chapter, which is chapter number 6 on site investigation. In this chapter, we're gonna be dividing into two parts. The first part will take into account of F1, which is on introduction, until F4 on groundwater table. Part 2 will take account into F5 and up to F10. A number of engineering properties of soil were presented previously. We've learned about stress distribution in soil, soil consolidation, soil compaction, and the most recent was on slope stability analysis. Evaluation of these properties is absolutely necessary in any rational design of structures resting on, in, or against soil. To evaluate these properties, it is imperative that geotechnical engineers visit proposed construction sites and collect and test soil samples in order to evaluate and record results in a useful and meaningful form. In this chapter, we'll be focusing much on reconnaissance, steps of soil exploration, which includes boring, sampling, and testing, and of course, a record of field exploration. Reconnaissance. This is a preliminary examination or survey of a job site. In general, some useful information on the area. It can be from a map or aerial photograph, will already be available, and a person who doesn't know can learn much about surface condition and get a general idea of subsurface condition by simply visiting the site, observing thoroughly and carefully and properly interpreting what is seen. The first step in the preliminary soil survey of an area should be to collect and study any pertinent information that is already available. This could include general geological and topographical information available in the form of geological and topographical map, obtainable from your local authority. Now this is a topographical map of Peninsular Malaysia and also the West Malaysia as well. So from here, we can understand the elevation of an area. Take for example of Peninsular Malaysia. If it's near along the coastal area, it is of lowland. As it moves into the heart of the land, it becomes of higher ground. So that's the most basic thing we can interpret from topographical map. This is a geological map. This has a lot more information than a topographical map. For this map, the color shows different type of soil that exists in that area. So this is pretty much informative for making a decision in geotechnical engineering. Another type of information can be obtained by the use of photograph, or commonly known as aerial photograph. Proper interpretation of this photograph may reveal land patterns, such as sinkhole cavities, landslide, surface drainage pattern, and others as well. Such information can usually be obtained on a more widespread and true basis by aerial photograph than by visiting the project site. Specific details on this subject can be referred to a book available. Previously, we need to fly on a plane or a helicopter to take aerial photograph, but nowadays you can just lift up a drone. Now this is a project site somewhere near Johor. In Johor, it's about constructing a new line for the train track. As you can see here, this is the old line track, which is of single track line. And at the recent times, they want to develop a double track, which is on the right side of the old track. So this will cater 2 line tracks. So we were here to actually observe the surrounding areas for wind studies. Here's another set of photos that we had. So one can actually maneuver the drone from this car and send the engineers to look more deeper into the surroundings. So there are 2 engineers here. So what can you interpret from this photograph? Yes, correct. This is of lowland. If you can see the colors of the tree and some dark colors over here, it means it's going down, means it's a falling. Even for this part also is a small fall. So this is on the higher ground compared to the left hand side surrounding. Now here's is a bird's eye view of the track. And here's in the altitude of 200 meters above the ground. And here is the city center, right in the middle of Johor Bahru. That is Singapore, by the way. So this project becomes more complicated as you have development on the left and right side of the old existing track. Now, after carefully collecting and studying available pertinent information, the geotechnical engineer should then visit the site in person, observe thoroughly and carefully, and interpret what is seen. The ability to do this successfully requires considerable practice and experience. However, a few generalizations are given next. To begin with, significant details on surface condition and general information about subsurface condition in an area may be obtained by observing general topographical characteristics at the proposed job site and at nearby location where soil was cut or eroded, such as railroad and highway cuts, ditch and stream erosion and quarries, thereby exposing subsurface soil strata. The general topographical characteristic of an area can be significant. Any unusual conditions such as swampy areas or dumping areas such as sanitary landfills deserve particular attention in soil exploration. The next photo shows a swampy area. So as geotechnical engineer, we can make a fast decision when it comes to this type of land next to the old track. Because the presence of water is often a major consideration in working with soil and associated structures, several observations regarding water may be made during reconnaissance. Groundwater tables may be noted by observing existing wells. Here is a construction in progress. They are building sheet piles for the new construction of a bridge next to a heritage bridge. And from this bird's eye view, you can understand the overall surrounding at the construction site. Here is the city center on your left side, and on the right side is a more towards residential areas and oil palm plantation. Now here is a specific photograph from the top. So this is the heritage bridge that needs to be preserved, And this is the construction site of a newly developed bridge for the double track. So that's the sheet piling. From the preceding discussion on, one should be aware of the importance of reconnaissance with regard to soil exploration at a proposed construction site. In addition to providing important information, the result of reconnaissance help determine the necessary scope of subsequent soil exploration. At some point prior to beginning any subsurface exploration, it is important that underground facilities such as water remains, sewer lines be located to assist in planning and carrying out subsequent subsurface exploration. Geotechnical engineer doesn't just stays in the office like you have right now doing desktop studies. Some of them end up in the middle of the ocean. Some of them do the work underwater, and some of them in the middle of the jungle, and some of them right beneath the ground, which is underground. So it's a pretty exciting job. So that's the team that we had during the construction of double train track project. And that's my team. The most important thing about choosing a team is that everyone is following the leader. And things that we learn when you doing a project is that you gotta pray on time. That's how the project goes smooth. Let's look at the next subtopic, which is on step of soil exploration. So it consists of 3 steps. First is boring, second is sampling, and third is testing. Boring is pretty simple. It's just the drilling or excavating of hole in the ground, and then from there you take samples out and then you go for your testing. Pretty basic. So if you want to go detail into boring, this one will show you how a boring is being conducted. So a simple tool such as an auger is used for boring a hole. So this is a hand auger on your left side, and on the right side is a mechanical auger. So hand augers may be used for boring to a depth of about 6 meters. Power augers may be used to bore much deeper and quickly. Another type of boring method is test pits. This is the one I showed you earlier. So this guy is taking a photo in a test pit. This is a test pit, and this is a test pit as well. So from test pit, you're able to take a quick sample out and easily assess the strata of the area. Now, another type of method when it comes to rocks is core boring. Let's look at a final statement. Obviously, the more boring made, the better the analysis of a subsurface condition should be. Boring are expensive, however, and a balance must be made between the cost of additional borings and the value of information gained from them. As a rough guide for initial spacing of borings, the following are offered. For multi-story buildings, 15 to 30 meter. For one-story building, earthen dams and borrow pits, 30 to 60 meter, and for highways, subgrade 150 to 300 meter. This spacing may be increased if soil conditions are found to be relatively uniform and must be decreased if found to be non-uniform. Once the mean of boring and the spacing have been decided upon, a final question arises as to how deep the boring should be. Researchers did a lot of work on this, and they come up with a simple chart where we can determine the minimum boring depth for different criteria of foundation. For example, how to use this chart? First, you need to calculate the unit weight of soil. Next is the footing contact pressure, and then the footing width that involved, and then you can get your boring depth. It is pretty easy. The figures shown are quite useful for estimating minimum required test boring depth in cohesive soils. In the final analysis, however, the depth of a specific boring should be determined by the engineer based on his or her expertise, experience, judgment, and general knowledge of the specific area. Also, in some cases, the depth and spacing of borings may be specified by local codes or company policy. The next step is sampling. So we've looked at boring, and now we move on to sampling. Sampling refers to the taking of soil or rock from bored holes. So you're likely to get this type of sample from site. This is by using tubes. After you have taken sample from the site, this is where the main thing comes in, which is the testing. A large number of tests can be performed to evaluate various soil properties. These include both laboratory and field tests. Some of the most common tests are listed in table. The field tests, the standard penetration test, cone penetration test, and vein tests are described in a later chapter, which is in part 2. These are common type of testing that you have been assisted previously. So we have a property of soil, grain size distribution. The type of test is mechanical analysis, consistency, liquid limit, plastic limit, plasticity index, unit weight moisture, shear strength, and so on. So these are the standard testing that you're gonna do later in your career when it comes to geotechnical engineering. Don't forget to subscribe or be a member of these governing bodies of geotechnical engineering. This helps to enhance your career in the future. Now let's look at the next chapter on groundwater table. The location of the water table is a matter of importance to engineers, particularly when it is near the ground surface. For example, a soil's bearing capacity can be reduced when the water table is at or near a footing. The location of the water table is not fixed at a particular site. It tends to rise and fall during period of wet and dry weather, respectively. Fluctuations of the water table may result in reduction of foundation stability. In extreme cases, structures may float out of the ground. Accordingly, foundation design or methods of construction may be affected by the location of the water table. Knowing the position of the water table is also very important when sites are being chosen for hazardous waste and sanitary landfills to avoid contaminating groundwater. So this is a apparatus that is used to measure groundwater. So this is a sensor, and you just need one person to insert the sensor inside the borehole, and then it will detect the water beneath the ground. Another approach is by using another type of continuous sensor monitoring. So at site, you like to know a continuous monitoring of water because water changes. So this is a well-kept groundwater monitoring station. Simple, fast installation. To know more about geotechnical studies, you might want to look at this established journal in the online. The most popular one is Earthquake Spectra, and then the Geotechnique. Before we begin to look into part 2, here is how we take a sample from site using the specific apparatus. This is a Macintosh probe, and you're likely to penetrate into the ground to get the level of hardness of the ground. Now, before we move on to part 2, let's detect some wrongs in this picture. Do you think anything missing? Yes, very good. They should wear proper attire for doing this type of job. Thank you very much. See you in part 2.